Hello, everybody. It's a very enigmatic title, but I'm not going to go into black holes and white holes. The combining of black holes and white holes may unlock the secrets of time travel. Now, I read this sentence in primary school about 9 years ago and was completely enthralled and mystified. Of course, being older now, I realise the sentence in fact means very little. The existence of black holes as physicists thought they knew them has never been more hotly debated. Never mind their combining with the still incredibly speculative white holes to unlock some great mystery. That, however, is not the point. The point is that this sentence was exciting and strange. It got me thinking about the absurdness of what's really out there. I can pinpoint the moment I read that sentence as the moment I realised the magic of reality, the awe which should be inspired at anybody who thinks about the world around them. I now realise my reading that sentence was the event which kindled my love of science. I realised that weird and wonderful things like black holes were really out there, commanding their place in the universe just as much as you or I. Not things that are confined to the minds of overzealous scientists in little rooms, but things to be studied by everybody and marvelled at by anybody who wishes to marvel. This sentence, with its 13 words but bizarre complexity, also made me realise the difference between knowing the name of something and knowing something. With knowing something comes an understanding of not only its properties and its effects, but also its composition and what its constituent parts say about other things. This is what I feel physics does at its best. It tries to understand where emergent properties emerge from. So that's what I want to achieve in life, to really know something, really know it. For that, I blame that slightly ridiculous sentence at the start, and for the rest of my 7 minutes, you can blame it too. A good place to start when trying to work something out is to identify what you don't know. Now, I'll do this by trying to give a brief explanation of a hydrogen atom. Every time I come across a chasm in my understanding, I'll just say so. Let's start with the atom as we know it. One proton, made of 3 little particles, with 1 electron whizzing round it, not orbiting, but occupying an orbital. The 2 particles have respective charges of +1 and -1, and the proton has mass 2,000 times that of the electron. Unfortunately, we've already come to my first problem: mass. Now, mass is a fundamental property of nature that can only be understood operationally, in terms of its own properties. That is, it can't be understood by what it is, rather by what it does. So what does it do? Well, objects of mass create gravitational fields that cause force on other objects of mass. So one could say that mass has the capacity to create a gravitational field. Mass, however, is also sometimes described as a coefficient of inertia. So the force applied to an object is proportional to its acceleration with a constant of its mass. So one could say that mass is something's resistance to acceleration. My question is, which one is it? Why are these two things the same? Why is something's inertial mass the same as its gravitational mass? Anyway, the proton and electron are bound together in this state called hydrogen. They are bound because of the electromagnetic force. This is the force felt by charged objects in the presence of other charged objects. But what creates the attraction between the proton and the electron? In one of Richard Feynman's books, QED, The Strange Theory of Light and Matter, he states, by exchanging virtual photons, the proton keeps the electron nearby. He then leaves it there. He just abandons it and moves on. I wasn't particularly satisfied with that. So, the virtual photons, it seems, are not really virtual, nor are they really photons. Where real photons are smooth ripples in the electromagnetic field, moving at the speed of light, virtual photons are confused disturbances that propagate between objects of charge. Unsurprisingly, we've reached my second problem. What does any of that mean? What I've said implies there is a constant background field, the electromagnetic field, and that when ripples appear in it, we observe particles of light. Does that mean all fundamental particles are ripples? And then when people say they're searching for particles, what they really mean is they're searching for new products of fundamental fields? I don't know. I think I've already failed comprehensively in my attempt to describe a hydrogen atom, so I'll abandon it there. I've not yet even uttered the words quantum theory, and I've confused myself completely. Anyway, I hope you weren't too bored or confused by my ramblings, and that you now realise how important that strange sentence was in shaping the way in which I wish to view the world, through the eyes of a scientist. To search for not only the aesthetic beauty of nature, but also the beauty in its infinite properties. I hope that one day I'll be able to do this, and perhaps contribute to other people's appreciation of nature in my own small way. I hope that one day I know something. I'll say one last thing. If at any point I get my hands on a black hole and a white hole, and somehow fuse them and create some sort of time machine, I promise to come back to this exact point in space and time.